I need to get my paper. My fault. What's going on, my people and my fellow students or whoever is watching this video? If you are struggling with your mechanics of solids course and you have an exam coming up and you don't know how to study for it, this is the video for you. I'm going to go over stresses, strains, and all the other nonsense using Mohr circle. What's a Mohr circle? Let's get into it. So the way I want to do this is that I kind of want to like explain it so that I can understand it, so that you can understand it. So this is based off of how I interpret it, right? So I'm going to be using example problems. These are for educational purposes only. Let's begin. So let's say if you have a stress element, right? Let's say this is your stress element in a 3D element, right? Let's say you have a force that's acting this way, 84 megapascals. Let's say you have a force that's acting this way, a force like this, a force like that, and a force like this, right? Let me make sure my numbers are correct before I further explain this. What am I looking at? Okay. This is actually supposed to be, well, it doesn't really matter. This is just to explain. So 70, 25, right? This is 50. This is 84. I kind of got the numbers switched up, my fault. So we're going to put this as 78, okay? So, and then we also got to mark our directions, right? So let's say this is your Z, X, and your Y, okay? So let's say you're given this problem on your exam, right? And the problem, or the question asks us, calculate the stress components that are acting along the X and Z direction. I think that's what the problem asks. Excuse me, the YZ direction. This is for the problem. But YZ direction, right? So you got your Y, you got your Z. So now we can label our stresses. We know that our stress in the Y direction is 84 megapascals, right? We know our stress in the Z direction is 50 megapascals. So we're going to mark that as 50 megapascals. So our whole objective is to identify what our stress components are. So now that we have two stress components along a plane, we can now calculate the average stress. How do we do that? Well, all you got to do is just do that sign. You do your stress in the Y plus your stress in the Z, divide that by 2. Once you do that, this is equal to 84 plus 50 divided by 2. What is that? 134 divided by 2. That's math. Is that 134? That is 134 divided by 2. $67. Let me confirm that with my calculator. So we got 84 plus 50 divided by 2. That is 67, if you can read that. So we have 67 megapascals. So now, what do we do with this information? I'm going to show you in a bit. So now that we have our average stress, now we have to calculate the radius whenever we construct our Mohr circle. So in order to do this, we have to, the formula is the square root of your stress Y minus stress Z divided by 2 squared plus your shear stress along the X or YZ direction. So where do we get this right here? Well, we have a force that's acting in the Y. We have a force that's acting in the Z. And if you go into your stress cube components, when it's all labeled out, you can see that whatever's acting in this direction, that's going to be your strain in the YZ direction. So that is going to be 25 megapascals. This is going to be 25 megapascals. So when we sub in our values, we do 84 minus 50 over 2 squared plus 25 squared. This is equal to 84 minus 50 over 2, so you do squared, plus 25 squared. That is equal to 30.23. So this is 30.23 megapascals. So now that we have our radius, if the question is asking, calculate your maximum shear stress, that is going to equal your radius. Why? I have no idea. But you will see whenever we construct a Mohr circle. So our radius is also equal to our maximum shear stress, or strain, excuse me. I keep on getting mixed up. So now we have our average, we have our radius, and we have our shear strain, our maximum shear strain. So what else do we need to do? Well, the question is also going to ask, calculate your principal stresses. How do we do that? So we got our principal stress 1, principal stress 2, principal stress 3. Make sure you guys can see that, right? So whenever we're doing this, right? Our principal stress 1, that is going to be our sigma average plus your radius, which is this right here, right? We have these values. Sigma 2 is going to be your sigma average minus your radius. And then sigma 3, that is going to equal the compressional stress that is acting on the cube, which is this force right here. So the reason why this is that force, because compressive stresses, those act in what direction? Negative, right? Or those are a negative force. And then whenever it's tensile, when it's pulling, that's positive. So think of it like this. Negative, right? And then positive, like, I don't know. It's just positive. So, like I said, compression, negative, positive. Good? All right, cool. So we have that. So this is going to be negative 78 megapascals. And just to note, whenever you're marking your forces, if one of these forces are acting on the cube, well, towards the cube when it's compression, make sure you put your signs. So if this was acting downwards, this would be negative. If this was acting that way, this would be negative. Cool? Cool. Okay. So we calculate these forces. We do, what is it, average? So we do 67 plus 30.23. This is going to be 97.23. And then this is 67 minus 30.23. This is 36.77. So now that we have our principal stresses, we can now construct the Mohr circle. How do we construct the Mohr circle? Well, let me make sure you guys are, you can see everything. So we have our y-axis, our x-axis. Our x-axis is going to be our stresses. Y-axis is going to be our strains, right? Make sure you guys can see that. I'm gonna put y'all a little more focus. Okay, cool. So create a big circle, just any circle, right? This area right here, this spot is going to be your stress 1. That right there is going to be your maximum stress. This right here is going to be your stress 2. Actually, no, excuse me, 3, because that's your minimum. So this is going to be negative 78, and this is going to be positive 97, right? Acts on the strain or stress axis. So we have that. So where does this go from? So this is 36. So this would be right here, right? This is stress 2, so this is 36.77. This right here is 97.23. And then this right here is 36.77. So now we can draw circles. We draw a circle here, and then we draw a big circle right there. And that is how you construct your Mohr circle with your principal stresses. So remember, just to go over everything, okay? You're given a stress cube. You have your forces in a certain direction. You label what your stress is on whatever plane the question is asking. You mark and you identify those stresses. Once you have those, you calculate your average stress, you calculate your radius, and then in order to get your strain, figure out which one of these are acting inside of the cube, which is, we got that right there. So we got 25. Remember, your radius is also equal to your maximum strain, which is that right there. And then once we have all these values, we can now calculate our principal stresses, principal 1, 2, and 3. So we do our average plus our radius. We have our average right here, have our radius right here, add those up. That's our maximum stress. And then to get our minimum stress, actually no, this is our minimum stress. This right here is what's going to be in the middle. So we do sigma average minus R, we get this. Now, you may be wondering, what if this right here, or how can I know what to put for each one? On some of the questions, like the other ones, they could say all of the other stress components are 0. Whenever you're given that case, what you do is you have whatever's in the middle, which is your stress 2, you have that equal to 0. If the problem states specifically that your stress in whatever direction, X, is this, and your strain is whatever, and all of the other components are 0, you always have your second stress equal to 0, okay? So, there's that. Now, as far as angle-wise, I still need to learn about that. But, just to give you a little rundown of what you'll, go over in your problems and all, this is how you construct Mohr circle when you're given an element. All right, so hopefully this video helps you guys out. Good luck on whatever exams you guys got going on. Comment down for any suggestions. And yeah, good luck on your exams. You got it. Don't freaking force anything. Trying to stress yourself out, and you'll be all right. All right, so that's how you do it. Mohr circle.